Do you enjoy drawing nice tile maps? Well, maybe your players would do this too. That intro sucked. In this tutorial series, you will learn how you can create an in-game UI where your players can draw on a grid. We are going to use Unitys Tilemaps, and there will be a lot of coding involved. So you should know the basics of Unity and about coding with Unity. But I am also going to explain a lot. Here you can see the content of the currently planned parts for this series. So let's not waste any time. I start with a new 2D project. I already made some example tiles, which are inspired by RimWorld. Let's start by preparing the tiles. I add the image to my sprites folder and adjust the settings as needed. I can slice this image by cell size with a size of 100 by 100. Every box is now a single sprite. If you use your own sprites, just make sure that every sprite has the same size. But like the door here, it can have transparent parts. Since we want to draw on a tile map later on, I will create one, a default one. After creating a tile map, you can open the tile palette editor by clicking this icon right here. This will be only shown where the tile map is selected. Create a new palette, which will be only used for our items, which are buildable for the user. Now drag and drop your tiles into the palette. Doing this the first time, you will be asked where to save the resulting tiles. I create a tiles folder therefore. Check if you can paint with your tiles on your tile map and that everything matches. So those are the tiles we want to be able to draw with later during runtime. For this step, we will work with so-called ScriptableObjects. These are objects whose structure is defined once by code, and from which you then can create the specific objects manually or by code. In our case, we create them manually and thus decide which building objects are available. At first, we need a folder for all our scripts. Now let's create a script which will define the structure or the base of our building objects. The name of your script, and therefore the generated class name, will define what your objects are. You can remove those two methods. Now it's important that this class derives from ScriptableObject, not from monoBehavior. If this is done, you can add this line, which will create an entry in the Create context menu, so that we can create objects from this class by using the Unity interface. For now, we want 3 properties for every buildable object. The name, where we will simply use the file name, the category this item belongs to, and the according tile base. So what exactly will be drawn onto the tile map later on. For the category, I will simply create an enum which holds 2 values, wall and floor. And even if the door might seem different, it is really similar to a wall, so it will belong to this category. Now let's create 2 serialized fields, one for the category and one for the tile base, so we can set the values of those variables from the Unity UI. That other scripts have access to those variables, I also add public getters, which will just return the private variable. This is everything for here now. Back in Unity, I will expand our folder structure. I create a folder Scriptables, where every scripted object we are going to create will be in. To be more specific, I create a folder in there called Buildables, so we can place all our building objects in there. To give it even more structure, I create folders for different kind of buildables. But this is not code or category related, just my personal style. Questions, feedback, or just the urge to talk? Join my Discord. When you now right-click and go to Create, you can see the entry we defined in the building object base script. You can create an object of this type. Like I said, we are going to use the file name as universal name. So if you're going to work with an I18N, you might need a separate field for this. My 2 serialized attributes are now ready to be filled. For the category, it already selected the first entry, which fits here. To select the tile base, you can either click on the point button here, but this comes without previews. So it's better to select your tiles folder and drag and drop the needed tile into the slot. I will do this for some examples, and I also recommend you to just use a few examples for now, because we will expand those attributes here later on, and you don't want to repeat this for every one of your objects. Now that we know we have walls and floors, it just makes sense to have those tiles on different tile maps. Something like this, a separate map for the walls and one for the floor. But doing this manually is way too inefficient. How to automate this will be shown in the upcoming next video, so don't worry. Don't create this, I just forgot to delete them. We will do everything on the default map. But what we are going to create manually and automate later is the UI. The user must be able to select whatever he wants to draw before he can draw. Yeah. For this, we will add a canvas to our scene. I make it scale to the screen size with a 1080p resolution. I create an empty game object for the overall overlay, which I span in the lower left corner. So the build UI will always be visible there. Now I want a wrapper for my categories. Note that those categories here are mainly for decorative purpose, just what the user can see. This doesn't have to match to the categories from the ScriptableObjects. Add a vertical layout group to automatically align all those categories. I want the anchor to be on the bottom left corner, and remove the checkboxes for child force expand. I then create an empty game object, again, for one category. The category itself will have a background, which is just white for now, and a text. I'll give this just an example look. Feel free to design this your own way. I add a horizontal layout group to the category and set the text as a child of the background. On the same level, I create a new empty game object, again, for the items, which will belong to this category. A horizontal layout group will help us aligning the entries. Remove the child force expand checkboxes here as well. For this wall there will be two wall objects we created earlier, but I don't name them explicitly now. An image component lets the player see what they can select. You can select an image by clicking the circle icon to the right. Be aware that this field wants a sprite, which is not one of the tiles we created earlier, but rather those single entries in your sprites folder. I repeat those steps for our other examples, the floors and the door. The latter one will be grouped as item, so that you can see there is no reference to the other category, where we selected wall. So, what do we want to achieve now? The user clicks on one of the items, and the according tile gets selected, and the user can draw it. The click event itself is easily handled by adding a button component to those items. So let's do this first, on one of our items. I choose the wooden wall for now. We could now use the default onClick handler, but this is where the second part comes to play. How do we know what we clicked? Currently, we only know this is the wooden wall because of the sprite we can see. But the sprite is just loosely connected to our created building object, which is the real wooden wall we want. So I'm using a different approach. I create a new script called BuildingButtonHandler. We need to import the UnityEngine.ui package. So we want a connection between the UI object and the according building object base. That's why we need a serialized field for this. I also want to reference the button for the item, where the script will be located. In the awake function, I get the button component and assign it to the button variable. When the button gets clicked, I want to call my buttonClicked method. And for now, I just log that it was clicked and show the according building object. By referencing the name attribute, we will print the file name. That's it in the script for now. Now I just add the script to my wooden wall object and assign the building object base. Now we know for sure this is the real wooden wall, not just a sprite in the UI. Repeat adding the button and the script, as well as selecting the according object for your other items. When I now start the game, and click one of my buttons, I can see the output of the console. It shows the according object, and of course also detects the click event successfully. A little information for you. I will showcase different things you can improve with this base idea, but of course creating a really nice and even powerful level builder is way too big. But if you have wishes or ideas, besides the here listed points, which will be done in the upcoming episodes, let me know in the comments or join my Discord. I'm definitely planning on doing some updates based on your wishes. Now that we can select items, we want to draw them onto a tile map. Besides the click event on the button, we must now be able to detect player clicks for placing a tile map, and for the next video also hold events. Those of you who know my videos know that I usually use Unity's new input system. So of course, I am going to use it in this tutorial as well. But if you know what you do with the old one, you should not have problems adapting this approach. Install it by going to Window, Package Manager, select Unity Registry, and find the package called Input System. During installation, you have to accept the prompt and Unity will also restart. Even if you haven't used the new input system before, you will still be able to follow along. But for more detailed explanations about the why, watch my tutorial series about this topic. I create a folder for the inputs, and in there my input action file. Inside my action map, gameplay, I am going to add 3 input events. The first and the second one will be left and right mouse click. It's from the default action type, button. The third one is the current mouse position. Select value as action type and vector2 as control type. Don't forget to save, and that's it for our inputs. I prefer working with inputs as C# classes. So hit the checkbox to generate one. Change the file path so that it gets generated into your scripts folder and click apply. In your scripts folder is now a new script named like your input action file. Since we already created a canvas, Unity automatically added the event system to your hierarchy. After switching to the new input system, you just need to check this button to switch it over to the new one. Now we can start the building process. Let's add a script for this. I call it BuildingCreator. To give this code a professional look, I am going to use Singletons. Well, no, I use them because I like them and they fit here. But don't worry, you just need to copy a script into your scripts folder. I use a little adapted version of the one InGame provides with his tutorial, but you can just use the one from him. Or mine, it's linked in the description. If you want to know more about singletons, you can watch the video. It's also linked in the description. Drag the script into your scripts folder, and like I said, that is everything you have to do with it. Now open your BuildingCreator script. The Singleton class already derives from monoBehavior, so it's fine for us to derive from Singleton. Give your current class name as type for the Singleton. And we will later need the Unity engine.inputSystem package, so add this to your imports. Since we generated a C# class for our input action, we can now declare a variable of player input. If you named your generated script differently, you must change the type here. Due to the use of the singleton, the awake function looks a little bit different. We use the access modifier protected, like it is in the singleton script, and add the keyword override. To make sure the original awake function still gets called, you need to add base.awake, so manually call the awake function from the class we derive from. Now we can instantiate a new object of class playerInput. Inside your onEnable and onDisable functions, you can now enable or disable your inputs. Now we can add methods that will do something if one of the defined inputs is triggered. Let's start with the mouse position. I declare a vector2 variable for the current position. Whenever the mouse gets moved, this variable gets updated. Add this onMouseMove method. The parameter is the current context of the input action. From this variable, you can read the vector2 value, which we defined earlier, with the readValue method and save it into your mousepos variable. In the onEnable function, we now tell Unity to call this method whenever the input mouse position has a performed event. In the onDisable method, we will remove the method call. This avoids potential memory leaks. Now let's do the equivalent for the left and the right mouse click. We will also react on the perform event, which is the best for simple click events. But I won't do anything in those methods for now, just that they are there. Currently, we have the ability to click an icon and know the according tile, but the information is in the building button handler script. To get it inside our BuildingCreator script, we create a public method which can be called from the button handler. The parameter of type BuildingObjects will be written in a variable. But since it might be possible later that we want to change or reset several things when this variable gets changed, I create a setter. And only change the value via this setter. The setter is written with a capital first letter, so I just need to change this part in my object selected method. So, what will happen now? Wherever the mouse is, I want the tile it's currently located in to show the preview of the selected tile. When I then left click, the tile should be drawn onto the tilemap. By right clicking, I deselect the current item and there should not be any preview. So this means, besides the tilemaps the objects get drawn onto, we need a preview tilemap. We can draw the selected object onto this tilemap and remove it as needed. I add a serialized field for this preview map. To work with tilemaps, we need to import the according package. I create a separate variable for the tile base variable from the selected object, so that it's easier available. And I also need two vector3int variables for the grid positions. The first one is the position on our tilemap the mouse currently hovers, and the second one where it was before, so that we can delete what we have drawn there. At last, I add a variable for the camera and assign the value of camera main to it. Let's do something with the variables. Inside the update method, I am going to transform the current mouse position, which is saved inside the mousepos variable, to its world position. With this world position, I can now go to the preview tilemap and ask which cell this position is in. If this cell is different than the value of our current grid position, I will save the old value to the according variable and replace it with the new position. So now I know always which cell my mouse is located in, as well as the previous cell. From this point on, I can update the preview. This will happen in an extra function. What we want to achieve here is to remove the tile which is on the previous cell and therefore set a new tile on our current position. This can be easily done with the setTile method. The first parameter is the position and the second one the tile base. A tile base of null removes any previous tiles from this position. But currently all the calculations inside the update function also happen if nothing is selected. So let's add a simple if statement which checks if there even is an object selected. And since we decided to use the tile base in a separate variable, we need to fill this variable whenever selected object changes. That's why it's handy to use a setter here. With a ternary operator, I check if selected object is not null. If it is not null, I get its tilebase variable, else I set the value of the local tilebase variable to null. And we will also call the update preview method here, so we can make sure any drawn preview tile will get instantly replaced with the new tile. We can now prepare to test the script up to this point. At first, we need to connect the building button handler with the BuildingCreator. I add a variable to save the reference of the BuildingCreator instance and assign the value in the awake method. This process here only works this way because we use the Singleton. Now I can call the public method we created and pass the building object base, which belongs to this button, to the BuildingCreator. where it is saved as currently selected object. Back in Unity, we need to add a new tilemap, the PreviewMap. I also add an empty game object, which will hold all our global scripts. This is the place where we add the BuildingCreator script. Now we just need to assign the PreviewMap to the according slot and can test everything. I can select an item and we have a preview. For every tile where we are, the preview tile changes its position. As long as I move inside the same cell range, nothing gets changed. If something is not working for you, rewatch and make sure you made everything correctly. And if you are tired from all the code, it's fine. That was the biggest part. Now we just need to place the tile onto the correct tilemap when clicking left, or resetting the selected object by clicking right. Let's start with the latter one. It's really easy. Back inside the BuildingCreator script, I jump to the still empty function, which gets triggered when we click the right mouse button. Now I can simply set the value of the selected object to null. Make sure to use the setter by writing it with the capital S. If the value was null before, it doesn't bother, so no additional if statements needed. When something was selected and I click the right mouse button, the preview gets completely cleaned. Like I said, easy peasy. For now, we want to draw everything on the default map, so we need a reference for this as well. I then add a new method, which will handle all our drawings. In the next episode, I will show you how to draw lines and squares. But for now, the only thing this method can do is call another one. The drawItem method is responsible for drawing a simple item on click. So all we need to do is setting the tile base to the current position in our default map for now. We just need to call the handleDrawing method on left click. But of course, this only makes sense when we have something selected, or else this would erase the click tile, which is not what we want. There is also another problem. Clicking a new button when something is selected also draws a new tile. But this can be easily fixed. Import the Unity Engine.EventSystems package. Now we can expand the if statement. We will check if the mouse is over a game object which interacts with the event system, like a button. And we only want to draw when this is not the case. That's it. Back in Unity, you need to assign the default map to its slot. Now we can left click and the tile kind of stays at the position. It is drawn onto the default map. This can also be seen here because the preview map gets rendered behind the default map. The preview disappears. This can be easily fixed by setting the order and layer value of the preview map to something high. So now you can draw simple things. Unfortunately, you can't stack them like a green floor with a door on top. So that's where one of the following parts comes to play, so stay tuned. Thank you for watching, and also thank you to everyone supporting me and the channel. Special thanks to my supporters on Patreon, Patrick, and Isuray, as a special thank you for you being the first one supporting me and thinking my content is valuable enough to support it financially. Thank you all. And as usual, if you enjoyed the content, consider liking and subscribing, and I'll see you next time.